Okay, ladies and gentlemen, we're going to continue with section 1.4. This is going to be where we pick up some of the formulas. Now, in this example, you're given the formula y equals the square root of 2x plus 1, and you're asked to evaluate the formula when x is 4. So this is simply a matter of basically taking a function, a rule that's given, and plugging in a specific value for x. So in this particular problem, I replace x with 4. That would give me y equals the square root of 2 times 4 plus 1. If you look under the radical, 2 times 4 is 8. 8 plus 1 is 9. The square root of 9 becomes 3. So the answer to this problem, when x is 4, y is 3. The next formula sometimes complicates people because some students have trouble remembering, and I'm pointing right to it, what a cube root means. So m is equal to 1/5 times the cube root of x. And in this case, we're putting in the number negative 125 for x. So come down with me. When you are trying to compute the cube root of negative 125, there are ways to do this on the calculator. However, right now with numbers this simple, there are just certain numbers you should know how to find cube roots of. Negative 125 is one of them. What you're being asked is this: what number multiplied by itself 3 times will give you negative 125? And that answer for that part is negative 5. The cube root of negative 25 is negative 5 because negative 5 times negative 5 times negative 5 would generate negative 125. So the radical disappears, the cube root of negative 125 becomes negative 5. We had the number 1/5 in front. When you multiply 1/5 times negative 5, you're left with the answer negative 1. All right, let's move on down. Okay, the next formula involves absolute value. H is equal to the absolute value of x minus 5. We're putting in 2.7 in the place of x. So inside the absolute value bars, we have 2.7 minus 5. That computation gives me a negative 2.3, but remember that it's inside the absolute value bars. The absolute value of negative 2.3 becomes 2.3. So the correct answer here, when x is 2.7, h is 2.3. All right. Now, in this particular problem, you can see from the lesson plans that the correct answer is choice 3. But here's how you know. When you look at this table that you're seeing, x is a list of numbers that goes across the very top row. And we have the numbers 1, 2, 3, and 4. Y is a set of numbers that goes directly under it, 2, 6, 10, and 14. Now, what you're really looking at here is you're really looking at a set of ordered pairs. X is the input and Y is the output. So when you look at X is 1, that means Y should be 2 since it's directly under it. So the ordered pair 1, 2 should make whatever formula we choose as our answer work. Likewise, the ordered pair 2, 6 should work. Likewise, the ordered pair 3, 10 should work. Likewise, the ordered pair 4, 14 should work. Therefore, the best way to determine what formula works is to try out the different formulas and to see which formula works. And I think it's pretty clear here when you look at the work, you'll see that the formula that works is formula number 3, y equals 4x minus 2. When I plug in a 1 to that formula for x, I get out the answer 2. When I plug in a 2, I get out the answer 6. When I plug in a 3, I get out the answer 10. And when I plug in a 4, I get out the answer 14. So it corroborates with all of the information in the table. In order to make sure you're picking the correct formula, it's very important that you test every ordered pair, because I could create a formula that might work for 2 of them, but then it wouldn't work for the other 2. So it's safest to check all of them. Okay? All right, let's continue. All right, the next question says this. Find the value of the variable a so that the equation y equals a times x models the data in the table. And they give us a table of ordered pairs. This time they're written where x goes down, it's under rather than across, and y also goes down. So, we're still seeing a collection of ordered pairs. -2, -10 would be the first ordered pair, -1, -5 would be the second ordered pair, and so on. This time, though, we're not trying to decide what the formula is. We know the formula. The formula is y equals a times x. We were given that. They just didn't tell us what the value of the variable a was. So the neatest way to do this kind of problem that I teach my students, I tell them to go to this table of ordered pairs and pick one of the ordered pairs. It doesn't matter which one you pick since they all work into the formula. So I happen to pick the ordered pair 210. So what I do, let me scroll down for you here, I go to the formula y equals ax, and since I know the ordered pair 210 is a solution, I put a 2 in for x and I put a 10 in for y. So that gave me 10 equals a times 2, and in order to get a alone, I divide both sides of the equation by 2, and that's how I get a is 5. So the best approach to this type of problem, when you're given the formula and you're looking for something missing from the formula, pick one ordered pair from the table that's easy to work with, plug the x value in, plug the y value in, and solve for the missing letter. All right? Very similar here on the next problem. We're told that d equals t minus a. T is the top row, which means that's our input row. D is our bottom row, which means it's our output row. We know the formula here is d equals t minus a. Go to your table and pick an ordered pair. I just happen to pick the ordered pair 0, 2. I could have used any ordered pair I wanted. Well, if I choose the ordered pair 0, 2 to help me answer this question, that means I go to the formula d equals t minus a, and I plug a 0 in for t because that's the input, and I plug a 2 in for d because that's the output. So I'm left with 2 equals 0 minus a, 2 equals the opposite of a, and of course if I'm solving for a, I can't leave that minus sign in front. So I multiply or divide both sides of the equation by -1, and I'm left with the answer a is -2. Okay, this is going to be enough for this part of 1.4, and we'll continue with it on another slide.